In this video, we will show you the workflow and steps for designing a cover of a transmission belt sprocket for a motorbike. In the first part of the video, we will reverse engineer the original part using 3D scanning technology. In the second part, we will design a new custom sprocket cover. The other side of the cover is a blend of flat and curved surfaces with recession for the bolt holes. On the internal side, there is a web network of reinforcing ribs to improve strength and rigidity. The peripheral faces are trimmed to match the geometry of the motorbike frame and engine case. We start by doing a 3D scan of the part. In this case, we use a mid-range infrared scanner for its simplicity and low cost. This type of scanner projects an invisible infrared light. An infrared camera captures the reflection and triangulates it to calculate the depth of each point of the part. We repeat the scanning process to obtain several meshes. The meshes are merged together into one reconstructed 3D mesh. The mesh is simplified before being imported into the 3D modeling software. Some pictures are also used as reference for the creation of the parametric 3D model. The motorbike is also 3D scanned around the area where the part will be fitted. We will use the scanned 3D mesh of the motorbike as it is, without further modeling. Having a 3D scan of the motorbike is very useful to validate the model of the part and to make sure it fits properly in place. Here we simulate a clash between the part and the motorbike. The parametric software makes it very easy to apply responsive changes to the design by just clicking the length of one dimension. The clash is now fixed. Using a circular section view of the assembled part, we can verify the alignment between the bolt holes on the part and the corresponding holes on the motorbike's frame. The clearance between the cover and the sprocket and the belt can also be verified. The parametric 3D model is created and can be exported into different file formats. It can be 3D printed for final testing on the actual motorbike before manufacturing. We now want to create a custom sprocket cover. A color transparent disc is bolted on the metal assembly. The main ring-like component is derived from a section of metal pipe. Its dimensions and openings are designed directly on the motorbike's model. This allows to immediately determine the correct position and clearances. The disc retainer is made of sheet metal. We assume that the metal sheet will be first laser cut and then bent. The modeling software allows us to unbend the model to obtain the flat profile. The type and location of the welds can also be modeled. Obviously, the assembly will be painted after being welded together, but here we want to make the weld location more visible. Once again, the parametric software makes any change to the model very easy. The lugged supports are positioned and included in the model. The welds are all placed, the model is now complete, and we are ready to produce fabrication drawings. The exploded view drawings shows the component of the assembly. A part list table includes a description of the parts and their quantities. Projected views of the ring component show the location and extent of the openings. The supporting lug's position is also identified. The retainer is shown in both bent and unbent configurations. A bend table is included and lists all the sequence and specification of each bend, only one in this case. This can be exported to DXF and DWG file formats for easy input into the laser cutter controller. A welding drawing shows type, extent and location of each weld. The drawings of the new custom part can now be issued to any workshop for pricing and fabrication. I hope you enjoyed this video. If you have any inquiry or if you wish us to assist you with your project, please contact us at admin@leansynergicdesign.com.au. Thanks for watching.